Hello, this lecture is for ME575 Materials of Additive Manufacturing. We'll focus on content from Module 4, specifically ceramics. My name is Jacob Strader. So the title of the paper for this report was Fabrication of a Ceramic Core for an Impeller Blade Using a 3D Printing Technique in Inorganic Binder. The three authors for this paper are shown below the title. It was published in the Journal of Manufacturing Processes in 2020. The scope of this paper is to study ceramic cores that are used for fabricating impeller blades. And these cores were prepared using two different 3D printing methods, and they're going to be analyzed to estimate future performance. The key questions addressed are, first, the strength of the material for both printing processes, and second, the thermal expansion of the material for both printing processes. So the process conditions examined are essentially the two printing processes. So for the first process is powder bed binder jet printing, short the BJP process, and then the second is selective laser sintering, in short the SLS process. Also, the researchers in this paper treat the ceramic material after printing in a inorganic binder, which the composition of that inorganic binder can be seen in Table 2 on the right of this slide. The specific materials used are a 190 micrometer quartz sand, a furon resin organic binder for the BJP process, and then a 70 micrometer mullite powder with a phenol resin organic binder for the SLS process. So the characterization tools are to measure fracture strength of both samples. A 3-point bending mode analysis was used, and a thermal expansion of both materials was measured at a heating rate of 5 degrees Celsius per minute up to a total of 1,000 degrees Celsius using a dilatometer. So the first key result of this study is the fracture strength. So as you can see on both of these charts, the chart on the left is for the BJP process, the chart on the right is for the SLS process. Fracture strength compared, the authors of this research paper compared the fracture strength for both processes, and they also compared it for pre and post heat treatment, and they also compared for treatment with the inorganic binder 1 time, 2 times, and 3 times. All of those conditions are shown on both of these charts here. So the takeaways from this are the fracture strength increases dramatically with the additional inorganic binder treatments. So as you can see there's a sharp increase from treatment 1 up to treatment 3. The fracture strength is consistently greater for post-heat treatment, and then the final conclusion is after all the treatments have been given to the material samples, the fracture strength is greater for the SLS process compared to the BJP process. The second key result is the thermal analysis. So again, the chart on the left is the BJP process, the chart on the right is the SLS process. So the outcomes of this are the BJP samples showed a thermal strain of 1.25% and a coefficient of thermal expansion of 13.2 times 10 to the negative 6. The SLS sample showed a thermal strain of about 0.5% and a coefficient of thermal expansion of 6.1 times 10 to the negative 6. So also, as you can see on these charts, the SLS sample thermally expanded uniformly with temperature, whereas the BJP sample oscillated with temperature. So the takeaways from this is the SLS process leads to a more thermally stable material. So the overall conclusions from this paper are the fracture strength of ceramic material used for the impeller blades has a higher fracture strength of the SLS process compared to the BJP process. Also, the fracture strength improves with heat treatment and with the additional inorganic material binder treatments. And then lastly, the SLS process leads to a more thermally stable ceramic material. Some personal critiques I had of this paper are, one, it's a very detailed analysis that looks at the critical mechanical and thermal properties for ceramic material used in impeller fabrication. Those material properties are obviously the thermal stability and the fracture strength. But in addition to that, I'd also like to understand the cost comparison of the BJP process and the SLS process to understand the benefits of each from that perspective. That's all I have. Thank you for taking the time to watch.